Okay, next one, fx is given like this, so square root of sin inverse x minus cos inverse x. We have to find the domain and range of this function. Since it is a square root function, it is exist for sin inverse x minus cos inverse x greater than or equal to 0. Since it is a square root function, it is exist for these values. Okay, sin inverse x minus cos inverse x greater than or equal to 0. And we have the formula like this. We know that sin inverse x plus cos inverse x is equal to pi by 2. We have to find the value of cos inverse x here. Cos inverse x is equal to pi by 2 minus sin inverse x. So replace cos inverse x with this function. Then it become sin inverse x minus of cos inverse x means pi by 2 minus sin inverse x greater than or equal to 0. So minus into minus plus, that means we have 2 sin inverse x and it is minus pi by 2 here. If it goes to right side, it become greater than or equal to plus pi by 2. So this is equal to sin inverse x greater than or equal to 2 2s are 4. That means sin inverse x is greater than or equal to 4. But we have the values like this. Sin inverse x, the maximum value of sin inverse x is pi by 2. Okay, sin inverse x always less than or equal to pi by 2. Okay, sin inverse x always less than or equal to pi by 2. So by using these two inequalities, we can write like this: pi by 4 less than or equal to sin inverse x less than or equal to pi by 2. Here sin inverse x is greater than or equal to pi by 4 and the maximum value of sin inverse x is less than or equal to pi by 2. So by using these two inequalities, we can write like this. Now apply sign for entire inequality. Then we get the domain of x sin pi by 4 less than or equal to sin of sin inverse x less than or equal to sin pi by 2. Okay, apply sign for entire inequality. Sin pi by 4 means we have the value 1 by root 2 less than or equal to sin of sin inverse x. We get x less than or equal to sin pi by 2 means it is nothing but 1. Therefore, the values of x lies between 1 by root 2 and 1. Therefore, domain of fx is closed bracket 1 by root 2 comma 1, closed interval 1 by root 2 comma 1. The values of x starts from 1 by root 2 to 1. Okay, so this is the domain of fx. Next, see the range of fx. Okay, continuation. Therefore, we have domain of fx is like this: closed interval 1 by root 2 comma 1. That means we have the minimum value of fx occurs at the value x is equal to 1 by root 2 and maximum value of fx occurs at x is equal to 1. Okay, so let us find the range of fx. Range, minimum value of fx occurs at x is equal to 1 by root 2. Okay, so let us find the value of f of 1 by root 2. F of 1 by root 2 means root of sin inverse 1 by root 2 minus cos inverse 1 by root 2. Sin inverse 1 by root 2 means it is nothing but pi by 4 and cos inverse 1 by root 2 also pi by 4. So under root pi by 4 minus pi by 4 means we get 0. So this is the minimum value of fx and maximum value of fx occurs at x is equal to 1. So that means f of 1 is equal to, so sin inverse 1. So sin inverse 1 means it is nothing but pi by 2. Sin inverse 1 means pi by 2. minus cos inverse 1, that means 0. So under root of pi by 2 minus 0 means root of pi by 2. Okay. So this is the minimum value of fx and it is the maximum value of fx. Therefore range is equal to closed interval 0 comma root of pi by 2. Okay. So this is the domain of fx and this is the range of fx. Okay. Thank you.